Section 3.5, rational function. In this part of the video, we're going to focus on graphing rational functions. Here are the steps that we're going to use to graph rational functions. First of all, make sure that it's always in lowest terms first. And then step 1 is going to be to find our vertical asymptote. Step 2, find our horizontal and slant asymptotes. Step 3, find the y-intercept by evaluating f of 0. That just means plugging 0 in for x and seeing what we get out. Step 4, we're going to find the x-intercepts. So that's by finding what values make f of x equals 0. Since our denominator can't equal 0, this is really just going to be setting the numerator equal to 0. Step 5, determine whether the graph will intersect its non-vertical asymptotes, so that would be its horizontal or slant, by solving for either of these two equations. Step 6, plot the selected points. We're going to do some testing in between each x value and the asymptote to kind of determine what our graph does in that area. We'll talk more about that in a minute. And then step 7, complete the sketch. So here we go, example 5. We're going to graph this rational function. First of all, I'll make a note that this is actually the same function from example 4, part A that we did in the notes. So we already know that our vertical asymptotes are at x equals 1/2 and x equals -3. So if you didn't remember that, you would just have to take the denominator, factor it, and then set each part equal to 0 and solve. Make sure that your asymptotes are written as equations x equal a number. For step 2, we also found in example 4a that we have a horizontal asymptote at y equals 0, which is the same thing as the x-axis, and we don't have a slant asymptote. Step 3, we're going to find out if we have a y-intercept. We do that by plugging 0 in for x. So if I plug in 0 for x and all 3 x's in my equation, I'm going to just end up with -1/3. We write our y-intercept as the point 0, -1/3. Next, we're going to find our x-intercept by setting our function equal to 0. Again, since our denominator can't equal 0, this is really essentially saying what makes our numerator 0. So we're going to set x plus 1 equal to 0 and solve. We get an x-intercept of -1. Make sure you write that as a point. Step 5, we need to determine if our graph intersects our horizontal asymptote, which remember is at y equals 0. We're going to do that by taking our function and setting it equal to our horizontal asymptote. So we have f of x equals b, which is our 0 here. Now remember, anytime we're setting our rational function equal to 0 and solving, it's just setting the numerator equal to 0 and solving. So we find that we intersect our horizontal asymptote at the point -1, 0. Since our horizontal asymptote is the x-axis, and we just found our x-intercept at -1, we probably knew this already, but I wanted to make sure that you saw the process in case it wasn't on the axis. Before we move on to step 6, we're going to go ahead and graph what we know. First of all, I want you to make sure that you have tick marks on your graph so that your graph can be easily read. And then we're going to start with our asymptotes. We've got vertical asymptotes at x equals -3 and x equals 1/2, horizontal asymptote at y equals 0. So we're going to show these by drawing dashed lines through those spots on the x-axis and through the y equals 0. Next, we're going to look at our intercepts. We have an x-intercept at -1, 0, and a y-intercept at 0, -1/3. Now, step 6 tells us to plot a point in each of the intervals determined by the x-intercepts and the vertical asymptotes to get an idea of how the graph behaves in each interval. So pretty much we're going to go through and discover what our graph is doing in each of these intervals. Let's start with this interval over here on the left side of our x equals -3 asymptote. I'm going to pick a number over here and see what happens as x is heading out to infinity. I can pick any number. I think I'm going to pick -10. When I plug -10 into this function, I get out a negative number. It doesn't really matter what the number is. All that matters is that it's negative. This tells me that my graph is going to be below my horizontal axis. My horizontal asymptote. So I know that as I draw my graph coming back this way, it's going to get close to the asymptote and shoot down. Next, we're going to focus in on what's happening in this interval between my asymptote at x equals -3 and my intercept at -1 on the x-axis. So the most logical number to test here would be -2. When I plug -2 into my function, I get out a positive number. Again, it doesn't matter what number it is, as long as I know the sign of it, whether it's positive or negative. So over here where x equals -2, I know that I have a positive value, so I know that my graph is going to be going up and shooting up to positive infinity. I already have another point between my x-intercept and my other asymptote, so I know that this part of the graph is going to shoot down. The last interval that I need to look at is this one to the right of my asymptote x equals 1/2. I can test any number on that side. I think I will test 2. When I plug 2 into my function, I get out a positive number, so that means that my graph is going to be above my horizontal axis. So I know it's going to go here and shoot up to infinity, and then follow my asymptote out to the right. I ended up doing step 7 in my last slide with step 6 because I was on a roll, but the last part would just be to sketch the rest of the graph with what information you know. So let's go over a couple of things really quick to make sure that you always have what you need to in the graph. You should always have asymptotes shown, so make sure that I can see those clearly. I also always want to see your intercepts. So I want to see a point at your x-intercept and a point at your y-intercept. Then I need to clearly see what's going on with the end of your graph. So I want to be able to see whether you're shooting up or shooting down. Example 6. We're going to graph the function 2x plus 1 over x minus 3. We're going to start with our asymptotes. We have a vertical asymptote at x equals 3. Horizontal asymptotes, the degrees of both the top and the bottom are equal. They're both 1. So we're going to do our leading coefficient divided by our leading coefficient. So we have a horizontal asymptote at y equals 2. We do not have a slant asymptote since our degrees are equal. To find our y-intercept, we're just plugging 0 in for x. When we do that, both of the terms with x's in them are just going to go to 0. So it's just going to be the 1 divided by -3 or -1/3. Make sure that you write your intercept as a point. Step 4, find your x-intercepts. That means to set our function equal to 0. Remember, anytime we set a fraction equal to 0, we're just really setting the numerator equal to 0 and solving. So we find that we have an x-intercept at -1/2, 0. Step 5, we're going to find out if our graph intersects our horizontal asymptote. We do this by setting our function equal to our horizontal asymptote, which we call b. And we're going to solve it and see if we get a solution or not. So first of all, I'm going to multiply x minus 3 to the other side to get rid of my fraction. Distribute the 2. Just rewriting the problem here. Subtract 2x over, and we get 1 equals -6. That's a false statement, so my answer is no, we do not intersect our horizontal asymptote. I'm going to start by graphing my asymptotes. I have a horizontal asymptote at y equals 2 and a vertical asymptote at x equals 3. No slants for this problem. Next, I'm graphing my intercepts. Make sure that I can see those clearly on your graph. Now we can go ahead and test some points in different intervals to figure out what's going on with our graph. Let's start over here on the left side of my vertical asymptote. I already have 2 points here, and I know that my graph isn't going to cross the horizontal asymptote, so I can just go ahead and draw this one getting closer and closer and flattening out. Same thing with it going down this way to negative infinity. Now I'll focus on the right side of the line x equals 3. I can test any number that's on the right of 3 on my x-axis. I'm just going to pick 4. So if I plug 4 into my equation, I get out 9. 9's positive, so I know that my graph is going to be above my horizontal asymptote. So here's what our graph looks like. Make sure that I can clearly see your asymptotes and your intercepts on your graph.